In this video, we're going to do a review of the 7 listed items. So we're going to talk about degrees of polynomials, writing polynomials in standard form, simplifying the sum or the difference of polynomials, a monomial times a trinomial, finding the GCF, using FOIL to simplify, and then finally multiplying special cases. I'll probably do about maybe 2 or 3 examples of each, move kind of quickly through them. If you have any questions, feel free to let me know. So first we're going to find the degree of the polynomial. So first example, we have negative 5a to the 8th. Now remember that we do not take into consideration the exponent of a coefficient. We only look at the exponent of the variable here. So this has a degree of 8. Second example, I have 4x squared y to the 3rd. Here, again, we do not take the exponent of the coefficient into consideration, and we will add the exponents we do see. So this has a degree of 5. We are going to now go over how to write polynomials in standard form. First up, we have 4x plus 3x squared. Okay, when you write in standard form, you want to remember that you go from the highest degree to the lowest degree. So from highest degree to lowest degree, from left to right. As we look here, we can see that we have an x squared, and then we have an x to the first. 3x squared is going to go first, then we put the 4x behind it. If this had a constant with it, then that would be the last term. Second example. Here again, we look for our highest degree. Our highest degree is a 3rd. Then we have a 2, and I'll put a 1 there just for good measure. So we list from highest to lowest. So I'm going to start out with 2p cubed. Then I go to my next degree down, which is the square, so 7p squared minus 3p to the first. On this slide, we're going to simplify the sum or the difference of a polynomial. So to start off, I want to decide, what am I doing? Am I adding or am I subtracting? Well, based on this addition sign right here, I am going to add this polynomial to that polynomial. And really what I'm doing simply here is I'm just combining like terms. Right, especially since this addition sign means that I don't have to change any sign back here. So I'm really just combining like terms here. It's the best way to think about it. So I'm going to start with my x squareds. I have 1x squared plus 3x squared, giving me 4x squared. Then I have a 6x on the left. I also have a 7x on the right. Combine those together for 13x, and then 11 and 4 gives me 15. And that is the sum of the two polynomials. For our second example, again, we're adding these two polynomials together. So what I'm going to do is start with my highest degree in either polynomial and start looking there. So On the left, I have a 5w to the third. As I look to my second polynomial that I'm adding, I don't have one there. So I'm simply going to rewrite 5w to the third. I like to cross things out when I use them. I find it helpful. All right, so that was to the third. Now I'm going to look for w squared. Here I have 3w squared plus a 7w squared. That's going to give me a 10w squared. Then just regular w's. I have an 8 and a 3, which gives me 11. And then I have my constants, 2 plus 1, giving me 3. Notice as I did that, everything ended up in standard form as well. For this simplification, I want you to notice I have a negative. So I'm going to be subtracting this entire polynomial from this one. The difference between subtracting polynomials and adding polynomials, with adding, you literally just combine like terms. With the subtraction, what you want to think about is distributing this negative to each term of the polynomial behind it. Almost like you're multiplying by a -1. So what I do is I rewrite the first and then distribute the -1 to each of the terms in the polynomial behind it. So -1 times 2x squared gives me a -2x squared. -1 times 7x gives me a -7x. And -1 times +5 gives me a -5. So now as I look at this, I have one nice long line of terms. And this is going to make your life so much easier as you go to combine like terms. All right, so let's look at our x squareds. Again, start with the highest degree first. So 4x squared minus 2x squared gives me 2x squared. And then I go to my x's. I have a positive 10x and a negative 7x, giving me a positive 3x. And then positive 7, -5 gives me a positive 2. All done. On this slide, we're going to talk about simplifying the product of a monomial times a polynomial. What do I mean by that? I am multiplying a single term by this polynomial. Here is a binomial, but it's the monomial being distributed to the polynomial on the inside. So example number 1, I'm going to distribute this 6x squared to the 4x squared. So I'm going to multiply my coefficients in the front. 6 times 4, 24. And then multiply x squared times x squared. Gives me x to the 4th. Then I multiply the 6x squared to the 3. 6 times 3 gives me is 18. There is no variable to multiply it with, so your final answer is simply 24x to the 4th times plus 18x squared. Second example. Here we're multiplying a monomial by this trinomial. So again, we're going to distribute. Multiply our coefficients. -8 times 3, -24. And then multiply your variables. C to the 3rd times c to the 2nd gives me c to the 5th. And then distribute again. -8c to the 3rd times 2c gives me a negative 16c to the 4th. And then our last term, -8c to the 3rd times -9. -8 times -9 gives me a positive 72c to the third. Pretty simple. Really all you're doing is just using distributive property. You've done that for a very long time now. Here we're going to be factoring out the GCF. GCF means greatest common factor. So I'm looking at the terms of this polynomial and I'm trying to figure out what can I remove? What can I take out of this polynomial? How can I simplify? Think about simplifying, right? Like you simplify fractions. So I want to ask myself, what number goes into 16, 8, and 20? What is the largest number that divides 16, 8, and 20? And the answer to that is 4. All right, then we want to ask ourselves, can I take out a variable? So here I have b to the fourth, here I have b to the second, and here I just have b, meaning b to the first, right? So notice all three terms have at minimum a b to the first. So I can take out a b to the first out of all these when I go to divide. So now what we're going to do is exactly what we're going to do. We're going to divide. So first divide your coefficients. So 16 divided by 4 is 4. And then b to the fourth divided by b to the first gives me b to the third. And if you're not understanding how that comes about, think about it this way. If I write it like this, that might make a little more sense. B to the fourth divided by b to the first gives you b to the third. Okay? Next up, 8 divided by 4 is 2. B squared divided by b to the first gives me b to the first. 20 divided by 4 is 5. B to the first over b to the first is 1. So it leaves me with just a 5. And that's it. That's factoring out the GCF. Let's look at one more. As we look at this, when we look at our terms, we notice that we could divide everything out by 11. Now notice that this term does not have a variable with it, so the only thing that we can take out of this is an 11. So 11 is going to go on the outside. 77 divided by 11 is 7x to the third. 22x squared divided by 11 is 2x squared. Negative 33x over 11 simplifies to 3x. And then negative 88 over 11 simplifies to just 8. And that is your answer as well. You might not always be able to take out a number and a variable. It's not always going to work out like that. Most of the time it does, but okay. Our last slide, we're going to be talking about multiplying special cases. So essentially here you are multiplying binomial times binomial, but there's tricks to some of these. So if we go ahead and look at the first one, where it's a plus b squared, I like these because it's so simple. Like you know what you're going to do. So you're going to square, and then you're going to multiply, and then times it by 2. All right, so what does that really mean? Let's take a look. So for x plus 3 squared, we're going to square the first term. We're going to square our last term. And then we're going to multiply the two things in the middle, which give us 3x, and times that by 2, giving us 6x. So your final answer is x squared plus 6x plus 9. Like, they're so easy. You just do that every time and it works. All right, let's do it again. Square the first term. So 3 squared and d squared. 3 squared is 9d squared. Square the last term, which is 100. Now, multiply the two terms together. So 3 times 10 is, you get 30d times 2, which gives you 60d. So final answer of 9d squared plus 60d plus 100. And you're done. They're like the fastest ones to do. All right, so that was the sum of a square. Now we're going to do the difference of a square. And this process doesn't really change except for one minor thing. Notice here, it was all positive, right? It was square plus, and then another one. Here, we're going to square the first, square the last, and then multiply times by 2, and then put a negative in front of it. All right, what does that look like? Square the first, square the last. Negative 7 times negative 7 is a positive 49. Here, negative 7 times x, we multiply together. Negative 7 times x is negative 7x. Times it by 2 gives us a negative 14x. So more cleanly, it looks like this. Super simple. All right, let's do it again. Square the first. 2m squared gives me 4m squared. Square the last. Positive 49. All right, multiply together gives me a negative 14m times that by 2 gives me a negative 28m. So 4m squared minus 28m plus 49. And last but not least, these are like the easiest ones out of all of it, because this is what we call a conjugate. When you have the same binomial with the only difference is this is a positive and that's a negative. And what that does is it cancels out that middle term. So it allows us to just square the first term, square the last term, and put a negative sign in the middle. Done. All right, so let's look here. Here we have a conjugate meaning a positive and a negative in between two of the same terms. So, story says, we square the first term, x squared, square the second term, 9, put a negative in the middle. That's it, done. All right, you're questioning, why does this work? All right, let's talk about why this works. So if you were to actually do the FOIL property on this, you would get x squared plus 3x minus 3x minus 9. Oh, wait, look what happens. The middle cancels out, so you're left with x squared minus 9. Again, the conjugates are my favorite because they're so easy. All right, here we go. Conjugate. We know it's a conjugate because two same terms, separate. One has a positive, one has a negative. So that means that we can square the first, square the last, put a negative in the middle. 7x squared gives me 49x squared. Square the last, gives me a 4, put a negative in the middle. Donezo. These are nice because they're super quick. If you know the rules, they're super easy. All right, that's the review. If you have any questions, let me know.